Now that we've removed unused CSS, we can move on to JavaScript. To keep the focus on web performance, we'll try to keep this as simple as possible and use a similar approach to the one taken with CSS, albeit a little more manual. Instead of having one global JS file which every page downloads, each page will have its own file containing only what it needs. Let's start by creating an index.js for our homepage. Next, we need to split the existing scripts.js file up into smaller partials organised by feature, so they can be easily imported where required. Create a new directory in the source.js directory called partials. Now back in the JavaScript file, move this header logic into its own file within the partials directory, like this. Then do the same for this scrolling function. Now we have our custom functionality all split up into separate files, let's import it. In index.js, we're asking the question, what does the home page need to function? All pages will need these, the lazy load polyfill, the cookie banner logic, and the header components logic. In fact, to save us having to import these manually for each page's file, let's create a new partial which can be the single source of truth for these shared imports. This way, instead of updating every page's JS file when new shared functionality is introduced, we just need to update the shared partial with the new import. So, what else is needed on the home page? Well, it contains some Bootstrap components, so we'll need Popper and jQuery. Instead of importing the entirety of Bootstrap, let's just import what we need: the carousel and the collapse component logic. That should save a few bytes. We also need the scrolling function. That should be it for the home page. Now what about everything else? Let's create the product page's JavaScript file and ask the question again. What does the products page need? Turns out, not a lot. All it needs is the shared functionality which every page needs. The same is true for the rest of the website's pages actually. We'd just be duplicating this file for blog and blog post. Instead, we'll rename products.js into default.js and implement logic into the build system which says, if a JavaScript file named after the page doesn't exist, it should download this instead. Now we need to bring all of this together and update the build tasks. So for each HTML page, if a JavaScript file with the same file name doesn't exist, default.js should be linked to instead. We first need to edit the head template and change this path to a variable called js_filename, as this is now a dynamic value. Then in the nunjucks task in the gulp file, we'll need to declare this variable and pass it alongside the existing filename variable, like so. Here, we separate the filename variable and then use it as the default value of the js_filename variable, which is correct, as if a JavaScript file exists which shares its name, we want to use it. We do this check here, using the native node module fs, which is short for file system. If a source file matching our current HTML file doesn't exist, set the JS filename variable to default, which will make the HTML request default.js instead. All that's left is to pass these values to nunjucks by returning them in an object, same as before. Now, for example, if projects.js exists, then projects.html will request it. Otherwise, default.js will be requested instead, which, as a bonus, will then be cached by the browser for when other barebones pages require it as well. Let's move this existing code down a little to make some space. We need to grab all of the HTML files from the roots directory and loop through them, like we did with the CSS. In here, we'll separate the file name and also create a new variable called filePath, which we'll use to point Gulp towards the page's JavaScript file in the source directory. So for example, when the loop is at index.html, filePath should point towards index.js. However, as we've discussed, there isn't always going to be a JavaScript file matching the current page. When this happens, we want both filePath and file name to match the default.js file in the source directory. Like in the Unused task, we can check if the file exists using the native fs module. Now let's take the old code and move it below here, pointing it towards whatever our file path ends up being, and naming it either after the current page in the loop, or if required, default.js. At the moment, we're using Bootstrap 4, which has jQuery and also Popper as dependencies. This changes as of Bootstrap 5, which at the time of recording is still in alpha, but nonetheless available to import via npm. With version 5, you no longer need jQuery at all, as it's all been rewritten in plain JavaScript. And as for Popper, according to the documentation, this has only ever been required for specific Bootstrap components, none of which LMLE Power is using. Therefore, we'll upgrade to Bootstrap 5 and eliminate these dependencies. In the command line, type this. Now we can safely remove the jQuery import, and since none of our components use it, the Popper import as well. On rebuild, the size of this file has dropped considerably now we've eliminated these dependencies. It's inevitable that you'll eventually receive a request from a stakeholder to add a tracking script to the website, and another request, and another. As a developer, it's your responsibility to police this as much as your role will allow for, as each of these tracking scripts incurs a performance cost. Measure the website's performance without the script, as then a cost-benefit analysis can be run to determine if the script is worth keeping. You can do this on Web Page Test via the Block tab. Just enter the domain of the tracking script here, and Web Page Test will do the rest. The report generated will then skip the tracking script completely, giving you an idea of what to expect if it were removed. Remember, with case studies like this, where Zalando saw a 0.7 increase in revenue when they shaved only 100 milliseconds off of their loading time, it's a conversation at least worth having. In this instance, I've spoken with the stakeholders at MLE Power about removing the Hotjar script. It's not been used to track visitors in over 6 months, but I've been told it's business critical. Here's a performance comparison showing its impact. The biggest difference here is the time to interactive metric, which is nearly 75% faster without Hotjar. This means users are able to have meaningful interactions on the website sooner, which at scale may be the difference between gaining a new customer or losing one. Thankfully, in this case, the stakeholder agrees with my assessment, so we can safely remove Hotjar from the head template. Unfortunately, these conversations rarely go this smoothly in real life, but it's important to have them regardless. The biggest changes here are to time to interactive and total blocking time, two JavaScript-oriented performance metrics. With time to interactive, it's simply a matter of having less JavaScript to delay interactivity. Whilst with total blocking time, I suspect the only remaining script which was complex enough to block the main thread was the Hotjar script. Therefore, removing it has resulted in this metric going down to 0. And then finally, less JavaScript means we have less code to download, meaning everything is fully loaded faster.